the DTI should be placed under the twist-off bolt head, put through the iron, and tensioned as it normally would. Again, this will verify that the twist-off bolt has been tensioned, and we will visually be able to examine that by seeing the protrusions on the DTI compressed to the proper gap. As you can see, the spline on the TC bolt broke off as it should. The gap on the DTI confirms that this twist-off bolt gave the proper tension when installed. Just another option for using DTIs. Many times in the field we see nuts and bolts in this condition. Now, one of the advantages of using a DTI will confirm whether this bolt, this twist-off bolt, reaches the required tension. We will put the DTI under the bolt head, put the bolt through the iron, tension it down, and see what happens. Now that we have installed the twist-off bolt in field conditions with a little surface deterioration, the inspector will come around and inspect it with the appropriate feeler gauge. As you can see, the feeler gauge fit in 4 of the 5 areas. The spline broke off prematurely due to the condition of the bolt. This bolt is not properly tensioned. Once the bolting has been completed, the inspector, using the required feeler gauge, will come around and visually and with the feeler gauge inspect each of the bolted connections. When the DTI is used under the bolt head, a 15/1000th of an inch feeler gauge is used. It should fit into less than 50% of the spaces available. When the DTI is installed under the nut, a 5/1000th of an inch feeler gauge is used. Again, the same rules apply. It should fit into less than 50% of the spaces available.